Noche cósmica.
Have you ever wondered what silence truly sounds like, when it is so complete that the very concept of sound becomes impossible? There exists a place beyond the reach of any wind, beyond the hum of any world, where emptiness itself has learnt to be still. It is called interstellar space, and it lives in the great dark between the stars, that vast, patient ocean of almost nothing that stretches across the universe, farther than human minds were ever designed to measure. And in this place, something remarkable occurs, not chaos, not violent turbulence or howling cold. Instead, there settles a kind of profound ancient quietude, a hush so deep that it becomes almost tangible, almost like something you might touch if you dared to reach into the darkness. For thousands of years, humanity looked up at the night sky and wondered what lay in those dark spaces between the points of light. We saw distance, we saw mystery, we saw something beyond our reach. But we did not know, could not have known, that the journey into that between space would one day feel less like an expedition into harshness and more like a slow, patient descent into rest itself. If you have ever found yourself drawn to content that explores the gentler truths of the cosmos, the parts of space that feel less like the violent theatre of supernovae and black holes, and more like vast, quiet chambers where time itself seems to breathe slowly, I invite you to subscribe. There are many more journeys through the calm dark between the stars waiting to unfold, many more relaxing facts about interstellar space that we will explore together, slowly, as the universe reveals its most peaceful secrets. Now, let us begin to understand what interstellar space truly is, and why its emptiness is not frightening, but rather settling. Imagine, if you will, that you have somehow left behind the solar wind, that constant, gentle stream of charged particles flowing outward from the sun like an invisible ocean current. You have crossed a boundary that few human instruments have ever touched, a threshold called the heliopause. Beyond it, the sun's influence fades into an almost unmeasurable whisper, and as that influence weakens, something happens. The air itself, or rather, what passes for air in the vacuum of space, becomes even thinner, more still, more peaceful. The sun's wind no longer pushes outward. The magnetic fields that shape it dissipate into threads so faint they are barely there at all. And in this new quietude, you encounter something that might feel, at first, like absolute emptiness, a void, a nothing. But it is not quite nothing, and therein lies a gentle truth that softens the mystery of the dark. Interstellar space is the realm that exists between one star's gravitational and magnetic influence and another's. It is the neighborhood outside the solar system, the region where the sun's light still arrives, years after leaving its surface, but where its power to shape and push and control has simply ceased. Here, in this strange in-between, the universe settles into a kind of patient equilibrium, a balance between almost everything and almost nothing. Do you feel the difference, even imagined, between a space where wind pushes and a space where nothing pushes at all? What is most astonishing about this region is how empty it truly is. If you were to gather all the matter, all the atoms, the tiny specks of dust, the wandering particles and magnetic whispers that exist in a cubic centimeter of interstellar space, you would hold in your hand something that contains roughly one atom, a single atom, lost in the vastness of a volume smaller than a sugar cube. This is not a metaphor for emptiness. It is emptiness itself, quantified and made real. And yet, somehow, this near-perfect vacuum does not feel like a hostile place. When held in the context of time and scale and the slow physics that govern the dark between stars, it feels like peace. Like a great room where nothing rushes, where nothing crashes, where the only sound is the faintest echo of ancient light that has been traveling for years to reach the spot where you are imagining yourself to stand. How strange that silence this complete would not feel like despair, but like rest. The oldest visitors we have ever sent into this realm are the Voyager probes. Voyager 1, launched in the autumn of 1977, has been traveling outward from Earth ever since, and for decades now, it has been sailing through the true interstellar medium. Not the near-solar region, where the sun's wind still pushes and shapes, but the genuine dark between. Its journey across the heliopause, that boundary between the sun's influence and the space beyond, took many years to confirm. Scientists had to watch the instruments carefully, noting gradual shifts in the behavior of the solar wind, subtle changes in the magnetic field surrounding the probe, tiny alterations in the density of particles colliding with its surface. And then, slowly, around the year 2012, it became clear. Voyager 1 had crossed over. It had entered the true vastness. It had left the solar system behind and begun its slow, eternal walk into interstellar space. Since that crossing, Voyager 1 has continued its journey, drifting deeper into the dark, sending back signals that take more than a day to reach Earth. Those signals are extraordinarily faint now, the power of a cell phone broadcast across billions of miles of emptiness. And yet they arrive, almost every day, carrying with them the faintest whisper of what that ancient probe experiences in the quiet between the stars. A whisper that speaks of profound stillness, of a journey measured not in months or years, but in centuries yet to come. And so, as you rest now, perhaps you might imagine what Voyager knows, that sensation of absolute silence, the absence of the solar wind's push, the settling into a rhythm so slow that millennia pass like heartbeats, and the universe around you becomes less a place of chaos and more a place of infinite, patient calm. There is something deeply settling about allowing your mind to drift across the vast architecture of what lies beyond our sun's reach. And if you find yourself drawn to these quiet explorations of the cosmos, these gentle investigations into the nature of emptiness and light and time, then perhaps you might consider subscribing to follow along as we undertake more journeys through the calm dark between the stars, each one unfolding at its own unhurried pace, each one designed to guide you toward the same sense of wonder and rest that emerges when we contemplate just how peaceful the universe truly is in its deeper reaches. There is no rush to this, no urgency in the way we might explore these truths together, and the idea itself that the spaces between stars could become a kind of sanctuary for thought, a place where the mind learns to settle into vastness rather than resist it, is perhaps one of the most unexpected gifts that astronomy offers us. When we think of subscribing to a channel or a series, we often imagine rapid updates and constant motion, but what we are really offering here is something far gentler, a slow, steady return to wonder, the kind of thing you might anticipate on an evening when you wish to let your thoughts drift outward, beyond the familiar boundaries of Earth, into regions where the natural rhythm of the universe itself becomes the metronome for your own breathing. The stories contained between the stars are among the oldest we can tell, and they are peculiar in this way. They do not demand anything from us except attention and a willingness to sit with silence. They unfold across such immense distances and such vast stretches of time that urgency itself begins to feel out of place. A light year becomes not a measure of distance, but a measure of patience. A cosmic cloud becomes not a distant object, but an invitation to stillness. So as we continue together into the definition of what interstellar space actually is, not as a scientific formula you must memorize, but as a threshold you are now crossing in your imagination, know that each subsequent exploration of this realm waits for you in the same unhurried spirit with which we have begun. The universe, in a sense, has already been waiting. The light that travels through interstellar space has been traveling for millions of years before reaching any eye to see it. What is a few moments of your attention, spread across future evenings, set against such cosmic timescales? What is subscription except another small act of patience, another way of saying that we wish to return, again and again, to the places where our minds feel most at rest? And so we arrive at a question that has quietly shaped human wonder for generations. What lies beyond? Beyond the warmth of our own sun, beyond the reach of solar wind, beyond the last whisper of our star's influence on the cosmos. This is interstellar space, not the vast emptiness we might imagine from science fiction, but something far more subtle, far more intricate, and vastly more peaceful than most people ever consider. Interstellar space is, quite simply, the realm that exists between star systems. It is the ocean that separates the islands of light we call stars. But unlike Earth's oceans, which churn with currents and life and endless motion, this ocean is profoundly, almost incomprehensibly still. It stretches across distances so immense that your mind, even now in this quietness, may struggle to hold them without slipping away into abstraction. To understand interstellar space, we must first understand where it begins. Each star, our sun included, is surrounded by its own sphere of influence, a region we call the heliosphere. For our sun, this boundary extends far beyond the orbit of Neptune, far beyond Pluto, all the way out to a region called the heliopause, at roughly 95 astronomical units from Earth. That is to say, if you were to travel from the Sun to Neptune and then onward into the cold outer reaches, you would pass the orbits of the ice giants. You would drift through the outer edges of the Oort cloud's whispered boundaries, and eventually, after decades of travel at human speeds, you would reach a threshold. This is the heliopause. This is where the Sun's dominion ends. The moment you cross that threshold, everything changes. Not with fanfare or sudden force, but with a gentle, almost imperceptible fading. The solar wind, that constant stream of charged particles flowing outward from the sun like an invisible breath, begins to die away. It does not stop abruptly, but rather diminishes, weakens, surrenders its momentum to the pressure of the interstellar medium beyond. And as the solar wind fades, something else begins to press inward. The wind of the stars themselves, the accumulated pressure of charged particles and magnetic fields drifting through the galaxy from sources we cannot always identify, from distant supernovae and stellar winds of other suns, all meeting in this boundary layer in a kind of cosmic equilibrium. It is perhaps one of the most peaceful transitions in all of physics, this quiet meeting of two winds, neither winning, neither losing, simply reaching a moment of balance and holding it across the eons. Beyond the heliopause lies true interstellar space, and what you find there is something that defies intuition. It is not perfect emptiness. The universe, in its profound wisdom, abhors a true void. Instead, interstellar space is filled with a gossamer medium, wispy, faint, almost entirely transparent to our instruments and our sight, yet present nonetheless. It is a thin fabric of hydrogen atoms, traces of heavier elements, and infinitesimal dust grains, all suspended in a magnetic framework so delicate that it seems, at first, to be nothing at all. This is where the profound stillness truly begins. With the solar wind's pressure removed, with the gravitational pull of your local star diminished to little more than a whisper in the cosmic distance, interstellar space becomes a place of almost meditative quietness. The particles here do not crowd together. They drift with vast expanses between them. When we speak of density in interstellar space, and density is perhaps the most soothing concept to contemplate in this context, we are speaking of roughly 1 atom per cubic centimeter. Imagine that, one single atom. In a space the size of a sugar cube, everywhere around you, for billions of kilometers in all directions, there is almost nothing. Just one atom here, and then nothing, and then another atom there, perhaps billions of kilometers away, and then nothing again. In this profound sparseness lies a kind of perfect rest. There are no collisions here, no chaotic interactions, no crowding or competition. Each particle, each lonely, wandering atom, has space almost unimaginable to share with its neighbors. Centuries might pass before two atoms came near enough to interact. Millennia might pass before a dust grain encountered another speck of matter. And yet, somehow, within this near-perfect emptiness, the universe still conducts its grand and patient work. Gravity still reaches out across these void-like distances. Magnetic fields still exert their gentle influence. The structure of cosmos is maintained, even in silence and separation, even in darkness that no eye can penetrate. To understand interstellar space is to understand patience itself. It is to grasp, in some deep and unspoken way, that emptiness is not failure, that the space between things is not a problem to be solved, but rather a canvas upon which time itself slowly unfolds. The boundaries of a star system fade not with drama, but with a fading whisper, and in their place comes something vast and calm and almost impossible to truly comprehend in its scale. This is the threshold beyond which we have, so far, barely ventured. This is the ocean we are only beginning to explore. And as you rest here in this knowledge, in this understanding of what lies waiting in the spaces between stars, perhaps you might feel, for just a moment, the profound and ancient stillness that has reigned there, unbroken and patient, since the earliest light first kindled in the darkness. The emptiness of interstellar space is almost beyond human intuition to grasp, and yet when you sit with the numbers, a kind of profound calm begins to settle in. One atom, perhaps a hydrogen atom, drifting alone through an entire cubic centimeter of space. To put that in perspective, a cubic centimeter is roughly the size of a sugar cube, or a small thimble held loosely in your palm. In the air around you right now, at sea level, there are roughly 25 quintillion molecules in that same volume. That is a 2 followed by 18 zeros. Interstellar space contains one atom. The vacuum between the stars is so complete, so utterly empty, that it almost ceases to be a place in the conventional sense, and becomes instead a meditation on the nature of nothing itself. Scientists refer to this as a near-perfect vacuum, and the word near is crucial. It is not absolute nothingness. Nothing with even one atom present is, in a manner of speaking, something. But the emptiness is so vast in proportion that the solitary atoms drift through distances that make their loneliness almost poignant, almost restful. Imagine if you took every person on Earth, all 8 billion of them, and spread them evenly across the Sahara Desert. You would look around and see nothing but sand and endless horizon for hours in any direction. That is crowded compared to interstellar space. Now imagine spreading those same 8 billion people across the entire volume of space between Earth and the nearest star system, Alpha Centauri, which lies 4 light-years away. You would never, in 1,000 lifetimes of searching, encounter another soul. The emptiness would be total. This is the scale we are considering, and it has a quality to it, something almost meditative in its vastness. Because the vacuum is so profound, sound, that essential companion of earthly life, simply does not exist there. There are no molecules close enough together to vibrate and create waves, to carry the tremor of disturbance from place to place. A star could explode mere light-years away, and the explosion would be utterly silent. Only the light would reach you, traveling across the void at its constant, patient pace. There is no wind in interstellar space. There is no echo. There is only the slow, methodical drift of particles so infrequent, so sparse, that they might take millions of years to meet one another again. And yet this extreme emptiness does not create an absence of presence. Quite the opposite, in fact. When you consider how little there is between the stars, you begin to understand that the universe is not a crowded place at all. It is patient. It is generous with its space. It offers room for light to travel, for time to unfold, for gravity to work its slow mathematics across incomprehensible distances. The near-perfect vacuum becomes, in a strange way, a canvas rather than a void, something capable of holding vast structures and timescales within it. The emptiness also produces a kind of thermal stability that is deeply gentle. Because there is so little matter present, there is very little to conduct heat from one point to another. An object in interstellar space loses heat through radiation only, which means it cools very slowly, settling into an equilibrium with the faint glow of the cosmic microwave background that permeates all of creation. This background radiation, a remnant of the universe's birth, maintains a constant temperature throughout interstellar space of approximately 2.7 degrees above absolute zero. It is, when you think about it, an ancient warmth that has been present since the beginning of time itself, a gentle embrace of leftover light from the first moments of existence. The vastness of this emptiness does something unexpected to the mind when truly contemplated. Instead of inducing panic or a sense of crushing isolation, it often produces the opposite effect. There is comfort in understanding that space is so enormous, so unfathomably empty, that any individual particle within it is relieved of the burden of density, of crowding, of pressure. Each atom in interstellar space has room to exist. It has freedom. It has the luxury of nearness to virtually nothing, of belonging to the largest, quietest cathedral ever conceived. In 1977, humanity placed two machines at the edge of the solar system and whispered to them, "Go." The Voyager probes, slender, golden, impossibly patient, were not designed to reach interstellar space, but they persisted anyway, through decades of silence and cold, becoming the first ambassadors we ever sent beyond the sun's dominion. And they are still traveling. Even now, they drift deeper into the dark. The journey they undertook is one of the gentlest, slowest conquests in human history. Imagine a vessel built from the technology of the 1970s, computers with less processing power than a modern greeting card, yet somehow sophisticated enough to still be sending signals back across the solar system 50 years later. These machines were designed to visit Jupiter and Saturn, to glimpse the moons of the outer planets, and then, their purpose fulfilled, to drift into silence. But engineers had built them to last, to endure, and so they kept going. They kept going for decades. For nearly 5 decades, the two Voyagers climbed outward through the solar wind, through the region of space still warmed and pressurized by the sun's breath. The solar wind, that constant exhalation of charged particles streaming from the sun, had always been there, invisible, a kind of celestial atmosphere extending far beyond the planets themselves. The sun does not simply shine light into space, it exhales. Billions of tons of plasma and particles flow outward every second, creating a bubble around our star, an invisible sphere of influence that reaches far beyond Neptune, far beyond Pluto, extending into what scientists call the heliosphere. The Voyagers moved through this bubble for decade after decade, and the world around them remained familiar. Cold, yes, distant certainly, but still within the sun's realm. And then, gradually, something began to shift. The solar wind does not extend forever. At some distance, and that distance is different in different directions, shifting with the pressures and rhythms of the galaxy, the sun's breath finally surrenders. It meets the interstellar medium. The atoms and particles flowing outward from our star encounter the denser gas of the galaxy, and where they meet, something remarkable happens. A boundary forms, a shock wave, a slow, invisible wall where two realms meet. Scientists call this place the heliopause. Helio for sun, pause for boundary. The place where the sun pauses, where its authority ends, where the vast galaxy begins to assert its own, more ancient presence. For Voyager 1, that crossing came in August of 2012. Think of that date for a moment. A machine launched before most of us were born, before personal computers existed, before the internet, before we even knew what the internet would become, finally crossed a boundary that humans had theorized about but never reached. Voyager 1 became the first human-made object to enter interstellar space. The signal carrying this news traveled at the speed of light, taking hours to cross the solar system to Earth, a gentle confirmation that we had sent something beyond the sun's reign. The crossing itself was not dramatic. There were no visible markers, no celestial fanfare. The probe continued on its trajectory, its instruments monitoring the flow of particles around it. But the numbers told the story. The density of solar particles dropped sharply. The magnetic field of the sun, which had been the dominant force, began to fade. The magnetic field of the galaxy, far older, far stranger, began to emerge. The instruments sensed a shift in cosmic rays, in the radiation drifting through space. The sun's protective bubble had released its hold. And Voyager 1 kept going. For years before and after that crossing, Voyager 1 was moving through a region of profound transition. Scientists call this region the termination shock, where the solar wind finally yields to the pressure of the interstellar medium. Even crossing the heliopause was not instantaneous. The boundary is not a sharp line, but a gradual, turbulent region where the two environments blend and negotiate. As if even at the edge of our solar system, nature prefers gentleness to abruptness, prefers long, slow transitions to sudden ruptures. Voyager 2, its twin, did not cross until 2018, 6 years later. 6 years of Voyager 1 journeying alone in true interstellar space, sending back its whispered measurements, its gentle confirmations that, yes, there was something out there, something beyond, and Voyager 2 would follow. The crossing itself revealed something unexpected and deeply calming. The interstellar medium near our solar system is relatively quiet. The bubble we had imagined, the shield the sun creates around its system, it seems to function in both directions. It protects us from the harder, more intense radiation of the deeper galaxy, while it also allows us to venture outward without immediately encountering the fiercest cosmic storms. We live, it turns out, in a gentle pocket of the galaxy. The boundary where we meet the interstellar medium is not violent but almost courteous. And the probes continue. They are no longer sending images. Their cameras have long since been shut down to conserve power. They are no longer collecting the data that made them famous. But they persist, drifting deeper into the infinite dark, still transmitting the faintest signals back toward Earth, still recording the density of particles around them, the intensity of radiation, the subtle vibrations of a universe we are only beginning to understand. It took them more than 30 years to cross that boundary, 30 years of gradual transition from the solar system we know to the galaxy we have only just begun to perceive. Every moment, Voyager 1 and Voyager 2 move farther away. The signals they send take longer to arrive. Soon, very soon in cosmic terms, they will have traveled so far that even light itself will struggle to carry their messages. They will have drifted into a silence so profound that Earth will simply lose them, not with drama, not with any tragic event, simply with distance and time, the same gentle forces that have been carrying them outward since 1977. But until that day comes, they are witnesses, messengers from the outer dark, carrying with them our first true knowledge of the place between the stars, the vast emptiness that separates us from all other suns, all other worlds, all other possible homes. They are proof, physical proof, that humanity can reach beyond its own star, that we can place a machine in the cosmic current and trust it to drift far enough, long enough, to touch the boundaries of the realm we have always wondered about but never quite grasped. And yet this silence, this profound stillness, is not cold in the way you might imagine, not the sharp, biting cold of a winter night, but rather a gentle, ancient warmth that has filled all of space since nearly the beginning of time itself. The temperature of interstellar space hovers around 2.7 degrees above absolute zero. 2.7. It is a number that sounds devastatingly frigid, and in a sense it is, and yet it is also something far more subtle and far less hostile than the phrase absolute cold might suggest. This faint warmth that permeates the void is known as the cosmic microwave background radiation, and it is perhaps one of the most profound and soothing discoveries in the whole of modern astronomy. Imagine that the universe itself is glowing, ever so faintly, in a continuous, gentle hum of infrared light. This glow is the oldest light that can ever be measured. It was released just 380,000 years after the Big Bang itself, when the entire cosmos finally cooled enough for light to begin traveling freely through space. Before that moment, the universe was opaque, a roiling fog of particles and energy. But at that threshold, something shifted. The fog cleared, light was born, and that first wave of light has been traveling through the expanding universe ever since, cooling and redshifting as space itself stretched and stretched, until today it arrives at us as a faint microwave glow, the universe's oldest heartbeat, still reaching us after more than 13 billion years of patient travel. What makes this temperature so remarkable, so strangely comforting when you pause to contemplate it, is that it is not a temperature of decay or emptiness. It is a temperature of equilibrium. The interstellar medium, that vast ocean between the stars, sits in a state of thermal balance. The ancient light of the cosmic background washes through it constantly. The sparse atoms that drift through this space absorb a tiny fraction of that radiation and emit their own faint energy in return. They are in conversation with the universe itself, a slow, imperceptible exchange that has been occurring since the universe became transparent. No extreme swings, no sudden shifts, simply a deep, patient equilibrium that has settled across all of space. And here is where the mind finds a kind of rest. The coldness of interstellar space is not a deadness, but a kind of stasis. It is an environment so still, so stable, that it has become almost a resting state for matter itself. When atoms move through this medium, they move with such deliberate slowness that their kinetic energy is negligible. They drift, they float, they are barely moving at all, and yet they are moving. There is almost no friction, almost no resistance. A particle that enters interstellar space today might travel for millions of years before it collides with anything at all. And when it does, the collision will be so gentle, so soft, that it registers as barely a whisper in the cosmic void. The actual measurement of this temperature, those 2.7 degrees, is something that took decades of careful observation to confirm. Scientists in the 1960s were puzzled by a faint static, a persistent noise, in their radio equipment. They could not eliminate it. They adjusted their instruments, recalibrated endlessly, and still this whisper of radiation remained. Finally, they realized this was not noise. This was the universe itself. This was the cosmic microwave background, the oldest light that exists, now cooled to the threshold of microwave frequencies through the expansion of space. The universe was speaking to them in the most ancient language of all, and they had finally learned to listen. What is perhaps most touching about this realization is that this ancient warmth is distributed absolutely evenly across the entire sky. Point your instruments in any direction, Up, down, sideways, backward through the cosmos, and you will find the same temperature, the same gentle hum. It is as though the universe has wrapped itself in a blanket, and that blanket is woven from the light of the very beginning, and it holds all of space in a soft, uniform embrace. There is nowhere in the cosmos that is truly isolated from this touch. Even in the deepest interstellar void, millions of light years from any star, this radiation is present. This background warmth is reaching you across the darkness, and it has been doing so since before there were planets, before there were complex atoms, before there was anything but the simplest elements born in the first furnaces of creation. And so when we speak of the temperature of interstellar space, we are not speaking of a harsh, rejecting cold, but rather of a kind of gentle, patient embrace. It is the temperature at which matter can rest without burning, without decaying rapidly, without being torn apart by extreme heat, or frozen into rigid stasis by deeper cold. It is, in a very real sense, the temperature at which the cosmos itself finds equilibrium, the temperature of patience, of ancient time, of processes that unfold across millions of years with such unhurried grace that they seem almost still to our rushing human perception. And yet, this emptiness you are drifting through, this near-perfect void, is not truly empty at all. It is filled with the gentlest possible substance, a presence so diffuse and ancient that it has been gathering between the stars since the universe itself was young. What lives in this space, in these vast distances between burning suns, is hydrogen in its simplest form, a single proton and a single electron, spinning slowly, radiating almost nothing, waiting in the profound dark. For every cubic centimeter of interstellar space, there exists perhaps one atom of hydrogen, sometimes two, sometimes less. A concentration so sparse that if you were to gather all the hydrogen atoms in a volume the size of a human body, their total mass would be less than a grain of sand. And yet across the incomprehensible distances between stars, distances measured in light years, in the journey that photons themselves take centuries to complete, these scattered atoms accumulate. They gather, they form clouds so vast that they span dozens of light years from edge to edge, and within those clouds, hydrogen begins to speak to itself through gravity, through the patient, eternal pull of mass upon mass. But hydrogen does not drift alone. Tangled within these cosmic clouds is dust, not the dry, lifeless dust you might find in an abandoned room on Earth, but something far stranger and far more profound. These are dust grains, microscopic particles formed in the hearts of dying stars, expelled outward in their final breaths, and now suspended in the darkness between worlds. A single grain is barely a millionth of a meter across, smaller than a speck of pollen, yet each one carries within it the compressed legacy of stellar alchemy. Carbon and silicon, iron and oxygen, all forged in the furnace of a star's core, now drifting as messengers between the living and the dead. These grains cluster together in the densest regions of hydrogen clouds, and as they do, they begin to block the light of distant stars, creating dark patches that astronomers call dust lanes, a visual quietness, a shadow falling across the luminous distance. Have you ever noticed how darkness itself can be restful? How the absence of light invites stillness? These dust clouds embody that principle on a cosmic scale. And threading through it all, invisible but unmistakably present, are magnetic fields. This may seem impossible in a space so empty, so devoid of substance, but magnetism is not a thing that requires density to exist. It is a force, a geometry, a landscape of invisible influence woven into the very fabric of space itself. These magnetic threads spiral outward from stars, carried on the solar winds of the past, and now they persist, holding their shape, their direction, like invisible architecture. They do not exert great force. A single magnetic field line is an impossibly delicate thing, but across the breadth of interstellar clouds, these fields guide the motion of charged particles. They influence the rotation of dust grains, and they shape the structure of the clouds themselves. The hydrogen atoms, as they tumble and drift, become aligned by these fields. The dust grains, spinning slowly in the dark, are oriented by them. It is as though invisible hands are gently shaping the medium, introducing a subtle order into what might otherwise be pure chaos. What emerges from this composition, hydrogen, dust, and magnetic threads all mingled together, is a landscape of astonishing delicacy. The interstellar medium is not uniform. It is threaded with structure, with filaments and tendrils, with denser knots and thinner voids. Imagine, if you will, a great dark ocean where currents and eddies exist not because of water in motion, but because of the magnetic fields guiding the drift of particles infinitesimally small. Some regions are dense enough to glow faintly when lit by nearby stars, creating the luminous nebulae that astronomers photograph with such reverence. In other places, the clouds are so thick that no light penetrates them at all, and they appear as absolute darkness, not the absence of something, but a presence of its own, a pocket of deepest rest within the larger darkness. Temperature, too, plays its role in the composition of this medium. Remember that the interstellar space is bathed in the cosmic microwave background, that ancient radiation left over from the birth of the universe, warming everything to just a few degrees above absolute zero. At such temperatures, the hydrogen atoms move slowly, their molecular motion reduced to almost nothing. They do not collide with one another in any meaningful way. They do not create pressure through their movement, as gas molecules do in the Earth's atmosphere. Instead, they simply exist, suspended in a state of profound calm, their motion so minimal that it barely registers. Yet even at these temperatures, the atoms do move. They vibrate, they spin. They are not frozen in absolute stillness, but rather in a gentle, patient dance so slow that it might take thousands of years for a hydrogen atom to wander from one location to another. Within this medium, the dust grains follow their own trajectories. Some are carried by the faint pressure of starlight itself. Yes, light, though it seems ethereal and weightless to us, does exert a pressure when it strikes matter. Over cosmic timescales, this radiation pressure pushes the grains slowly outward, away from the stars that illuminate them. Other grains drift with the magnetic fields, following the invisible lines of force like leaves caught in a current so gentle that their motion is imperceptible moment to moment, yet inevitable across centuries and millennia. These grains are coated with frozen layers of simple compounds, water ice, methane, ammonia, substances that freeze solid at the temperatures of interstellar space and remain frozen for eons. And so you begin to understand that this emptiness, this near-perfect vacuum between the stars, is not truly empty at all, but rather filled with a subtle composition of the gentlest possible materials. It is a medium that is silent, slow, and infinitely patient. It does not rush. It does not demand. It simply persists, threading hydrogen and dust and magnetic fields together in patterns that have been slowly evolving since the universe was young, and will continue to evolve for countless ages yet to come. In this way, the interstellar medium is like the mind at the threshold of sleep, still full of content, full of thought and sensation and structure, yet moving with such slowness and such gentleness that the listener may begin to follow its drift into the dark. Within these clouds of hydrogen and dust that drift through interstellar space, something extraordinary unfolds, though you must understand that extraordinary here means almost imperceptibly slow, a process that takes not years or decades, but millions of them, unfolding in a silence so complete that sound itself becomes a foreign concept. These are nebulae, from the Latin word for cloud, and they are perhaps the most patient architects in the universe. gathering the scattered atoms of space into the seeds of new stars through the gentle, inexorable pull of gravity. Imagine, if you will, a region of space where the density of particles increases only slightly, perhaps 10 or 100 atoms per cubic centimeter instead of 1, a concentration so gossamer thin that it would be an incomprehensibly perfect vacuum by any standard we know on Earth. Yet within this almost nothing, gravity begins its work. Gravity, that invisible force we feel every moment of our lives pulling us earthward, operates across the vast distances of space with infinite patience, drawing particles toward one another, strand by strand, grain by grain. The particles are so few that their dance toward one another takes millennia, but they dance nonetheless, gathering slowly around points of slightly higher density, accumulating in what we might call the cosmic equivalent of a whisper becoming audible. These accumulating regions, these cores of gentle aggregation, grow denser over time. More dust arrives from elsewhere in the cloud, pulled inward by the gravity of what has already gathered. More hydrogen molecules find themselves drawn into the forming clump. The process is so slow, so deeply gradual, that if you were to observe a single dust grain within one of these nascent stellar nurseries, you might not notice its movement at all across the span of a human lifetime. Yet move it does, pulled ever so slightly toward the center of mass, and in time, in deep, unhurried time, these microscopic movements accumulate into something profound. Within a large nebula, hundreds or thousands of these gravitational cores may be forming simultaneously, each one quietly gathering the material around it. Some cores may be separated by the distance of several light-years from one another, yet they exist within the same vast cloud, the same interstellar nursery. Each one represents a potential future, a possibility that gravity is patiently writing into existence. Have you ever considered that the stars which appear so distant and distinct to our eyes, separated by what seem like enormous gaps of space, may have been born as siblings in the same nebula, billions of years ago, and have simply drifted apart in the slow waltz of cosmic time? As a core continues to gather material and grow denser, something subtle begins to occur within it. The particles that fall inward begin to accelerate as they approach the center, converting the potential energy of the gravitational field into motion, into heat. The temperature within the core, which began at the frigid background temperature of space, gradually, almost imperceptibly, begins to rise. We speak of this as a gradual increase, yet we must understand that even after millions of years of accumulation, the temperature might still hover near absolute zero, near the cold cosmic equilibrium we discussed before. The heat is there, but it is a heat measured in the gentlest of terms, a warming that would seem like nothing compared to the furnaces we know. The composition of these nebulae varies in subtle ways across space. Some regions are denser in atomic hydrogen, that single proton and electron drifting together. Others contain more of the molecular hydrogen, two atoms bonded in pairs, slightly more robust, slightly more likely to accumulate. There are also heavier elements present, traces of carbon, nitrogen, oxygen, all created in the furnaces of stars that died long ago and scattered their ashes across space. These heavier elements, though rare, are crucial. They help the cloud cool, radiating away the small amounts of heat that accumulate, allowing the core to remain cold and to continue gathering material without heating up so much that pressure builds and halts the collapse. Dust grains scattered throughout the nebula play a role that is both humble and essential. These grains, though infinitesimal when considered individually, are not merely passive passengers. They are surfaces upon which molecules can form, chemical gathering places where particles meet and bond. They are also the source of much of the infrared radiation we detect when we observe these nebulae from afar, the thermal glow that tells us these quiet nurseries exist. The grains themselves are often coated with thin ices of water, methane, and ammonia, frozen hard in the cold of space, waiting perhaps to become part of a planetary system, waiting to contribute to the chemistry that, billions of years hence, might cradle life itself. What is remarkable about these stellar nurseries is how little needs to happen for gravity to accomplish its work. No dramatic collision is necessary, no explosion or violent event. The process requires only the patient accumulation of what is already there, the gentle drawing together of the diffuse material that drifts through space. Gravity, we might say, is the universe's most patient teacher, the force that whispers rather than shouts, that persuades through the constancy of its presence rather than the violence of its action. The timeline of these nurseries extends so far beyond human experience that it becomes nearly abstract. A core might take 10 million years to accumulate enough material to become what we would call a protostar, the earliest stage of star formation, when the core has finally grown dense and hot enough that the light beginning to emanate from it would be visible if we had eyes to see infrared wavelengths. Another few million years might pass before the temperature at the core rises high enough for hydrogen fusion to begin, the moment when the gravitational collapse finally halts and a true star ignites. Yet in the context of the nebula itself, in the vast expanse of cosmic time, this is remarkably swift, almost urgent in its own strange way. Consider what this means for the universe's future. In the darkness of space, in the quiet cold beyond the light of any star, gravity is at this very moment gathering the dust that will become the next generation of suns. The light from some of these future stars has not yet even been conceived, yet the material that will emit it is already coming together in the slow embrace of gravitational attraction. This process has continued for billions of years and will continue for billions more. A cycle of birth and death and birth again, written across the scale of cosmic time, powered by the invisible force that holds galaxies together and guides the very structure of existence. Within these nurseries, we find also something deeply comforting in the perspective it offers. The atoms that comprise your body, the calcium in your bones and the iron in your blood, once drifted in nebulae such as these. They were drawn together by gravity into a star. That star lived its life in the warmth of nuclear fusion, and when it finally died, exploded back out into space, where gravity once again gathered them, this time into the solar nebula that became our sun and our world. You are made of the dust of dead stars, yes, but more than that, you are made of the patient, gentle work of gravity, accumulated across the eons, a physical embodiment of time's slow sculpture. The nebulae themselves can persist for many millions of years, harboring multiple generations of star formation within their embrace. As young stars begin to ignite within them, their light and the gentle winds of particles streaming from them begin to interact with the surrounding cloud. The radiation from young stars may gradually disperse some of the remaining nebular material, clearing away the very dust that gave birth to them, in a process so gradual that it barely seems a conflict at all. Some regions of the cloud will remain untouched and intact, continuing to form new cores, new generations of stars, long after the first ones have ignited and begun their own journeys through the cosmos. In this vastness between the stars, something profound settles over everything. A silence so complete that it nearly has a texture, a weight, a presence of its own. If you could somehow position yourself in the depths of interstellar space, equidistant from any stellar furnace, you would hear nothing, not the whisper of atmosphere, not the tremor of vibration through solid ground, not even the faint electrical hum that fills Earth's cities and homes. There would be only the silence, the absolute, patient silence of a place where sound has no medium to travel through, where the vacuum itself is so thin that sound waves simply cease to exist. Imagine standing in that silence, and above you, scattered across an incomprehensible darkness, countless points of light, stars, ancient stars, distant stars, stars whose names we have given, and stars whose existence we may never catalogue, each one a sun, each one in its own corner of the cosmos, surrounded by its own planetary system, its own local sphere of influence. And yet, from where you stand in the dark between them, each star appears as little more than a pinprick, not because they are small, but because they are so profoundly, almost unimaginably far away. Starlight, you see, moves at the fastest speed known to exist in the universe. Nothing travels quicker than light itself. Nothing. And yet, even at that ultimate velocity, even racing across the void at roughly 186,000 miles per second, light takes years and years and years to cross from one star to another. The nearest star to our Sun, Proxima Centauri, is about 4¼ light years away. This means that the light leaving Proxima Centauri right now will not reach Earth for more than 4 years. When you see starlight from Proxima Centauri, you are not seeing where that star is today. You are seeing where it was. You are gazing backward through time itself. But Proxima Centauri is our closest neighbor. Move your attention outward, to the brighter stars visible from Earth on any clear night, and the distances stretch almost immediately beyond rational comprehension. Sirius, the brightest star in Earth's night sky, lies roughly 9 light-years distant. Betelgeuse, that ruddy giant in the shoulder of Orion, hangs about 650 light-years away. When Betelgeuse's light reaches your eye, it has been traveling in darkness for 6½ centuries. Kings ruled kingdoms, empires rose and crumbled, languages evolved beyond recognition, and still that ancient photon journeyed alone through the interstellar night. The light you see from Betelgeuse left its surface during the 1300s, and it has been falling through darkness ever since. Now consider, those distances, vast as they are, apply only to stars within our own galactic neighborhood. Our galaxy, the Milky Way, is estimated to span about 100,000 light-years across, a disk so immense that even light, traveling at its impossible speed, requires 100 millennia to traverse from one edge to the other. And beyond our galaxy, beyond the Milky Way, lies the local group, a collection of galaxies with the nearest large galaxy, Andromeda, sitting roughly 2.5 million light-years distant. Light from Andromeda has been traveling longer than human beings have walked upright on Earth. In contemplating these spans, the mind reaches a peculiar threshold. The numbers become so large that they lose their ordinary meaning. They are no longer distances in any human sense. They are not measurements of space so much as they are measurements of time, years and centuries and millennia stretching between stars like an invisible, patient ocean. In that darkness, in that infinite night broken only by scattered points of ancient light, there exists a profound quietness. Not the quietness of a silent room, which is merely the absence of nearby sound. This is a deeper quietness. This is the quietness of isolation itself. Any two stars, no matter how close they appear in the human imagination, are separated by years of emptiness. The nearest stellar neighbors still require years for light itself to bridge the gap between them. If two conscious beings stood on planets orbiting those nearby stars, the fastest they could ever communicate would be constrained by this immutable cosmic speed limit. Messages sent at light speed would still require years to cross the gulf between worlds. Consider what this means for the texture of the universe. Consider that this silence and this darkness are not anomalies or interruptions in the cosmic structure. They are not exceptions. They are the norm. They are, in fact, the very definition of interstellar space itself. The stars, for all their brilliance, for all their significance to us here on Earth, are actually scattered so sparsely through the cosmos that they constitute merely a trace element in the architecture of creation. Between them stretches the medium, the interstellar medium, thin, cold, composed of hydrogen atoms and dust grains and magnetic fields, a substance so insubstantial that it barely registers as existing at all, and yet it fills the vast majority of the space between stellar systems. The silence and darkness of interstellar space are not lonely in the way that word might imply sadness or abandonment. Rather, they are simply the natural state of separation. They are the baseline condition of the universe. For billions of years before human beings ever gazed upward and wondered, this silence existed. This darkness enveloped galaxies and nebulae and ancient stellar populations, and it will continue, unchanged, for billions of years beyond our present moment. In this middle region of comprehension, where the human imagination strains to hold the scales involved, where the numbers dissolve into abstraction, there is an unexpected comfort. The silence is not threatening because it is so complete, so absolute, so indifferent to human concerns that it passes beyond the threshold where anxiety can attach itself. It is simply there. The darkness does not press in because it is too vast to have any pressure at all. It simply is. In this vast darkness that surrounds us, time takes on a quality that earthbound minds rarely contemplate. When we speak of the distances between stars, we abandon our familiar measures. Kilometers become almost quaint, useless, like trying to measure an ocean with a teaspoon. Instead, astronomers speak in light years, a unit that folds time and distance into a single, gentle concept. A light year is simply the distance that light itself travels in one complete year, moving at its unwavering speed of roughly 300,000 kilometers per second through the vacuum. Imagine for a moment that you could ride beside a beam of light as it departed the sun on an ordinary day. That photon would race outward, crossing the entire span from Earth to the sun in just over 8 minutes. And then it would keep going, never tiring, never slowing, for 365 days, covering an almost incomprehensible distance before 1 year had passed. That journey, that celestial arc through the black, is 1 light year, and it is the ruler by which we measure the interstellar realm. The nearest star to our Sun, Proxima Centauri, lies 4.24 light-years away. What does that mean? It means that the light you see when you gaze upon Proxima Centauri has been traveling toward you for 4 years and several months. You are looking into the past, at a star as it appeared in the time of your memory, not as it is now. There is something deeply soothing about that, in a way. It suggests that time is not the hurried thing our daily lives convince us it is. Time, in the interstellar realm, becomes a substance, a medium through which light slowly drifts. That journey of 4 years is neither quick nor slow when you stop insisting on human speed as the measure. It simply is. It is a rhythm, a patient unfolding. Now consider this. If we sent a spacecraft traveling at the fastest speed our current technology permits, the Parker Solar Probe, which moves at approximately 190 kilometers per second, it would take that vehicle some 70,000 years to cross the Gulf to Proxima Centauri. 70,000 years. That is nearly 3,000 times the span of recorded human history. And yet, when we contemplate this number in the stillness of the interstellar dark, it does not feel tragic or overwhelming. Instead, it settles into perspective. It reminds us that distance and time are not enemies but companions, moving together through space in a slow, eternal dance. There is something peculiarly calming about understanding that no human life, no human ambition can bridge these gaps in the way we ordinarily think of bridging. We are bound to be slow travelers, if we travel at all. This is not a limitation that should distress us, but rather one that invites us to release our grasp on speed itself. When you accept that a journey to another star would consume centuries, you have already surrendered to a truth that might otherwise make you anxious. You have acknowledged the immensity, and in that acknowledgement found peace. Consider the vast majority of the observable universe, stretching outward in all directions. The Andromeda Galaxy, our nearest large galactic neighbor, lies 2.5 million light-years distant. If you could see light traveling through that distance, it would take 2.5 million years to cross it. To frame that differently, imagine a journey that would begin before humans walked upright on the African savanna, and would continue long after our species, in whatever form it takes, has either transcended or transformed beyond recognition. That is the scale of interstellar distance when we move beyond single stars to think of galaxies and clusters of galaxies. Yet here is where the mind finds its rest. Because these distances are so vast, they are almost abstract. They cease to feel like measurements and become instead like poetry, like the distance between dreams. We do not need to fret about them or overcome them. They simply exist, serene and unchanging, a reminder that some things are meant to be observed from afar, appreciated from a distance, held in the mind like a distant mountain glimpsed through fog. The interstellar medium does not rush toward us, and we cannot rush toward it. There is an agreement between ourselves and the cosmos, an understanding that we will remain in our solar system for now, warmed by our sun, and that the other stars will remain where they are, patient and ancient. When astronomers calculate how long it would take to reach other worlds, whether with advanced propulsion systems, theoretical wormholes, or methods we have not yet conceived, they are engaging in a kind of intellectual meditation. They are asking, quietly, what if? What if we had 1,000 years? 1,000,000? What if we could stretch our perception of a lifetime across generations, across epochs? These are not anxious questions but contemplative ones, the sort of questions that settle the mind as it approaches sleep, because they place human urgency in its proper cosmic context. They whisper to us that we do not need to solve everything today, that some journeys are meant to unfold across time we cannot personally witness, and that this, too, is a form of beauty. The light year, then, becomes not merely a unit of measurement, but a meditation on patience itself. Every light year crossed by a beam of photons, every light year that separates us from the next star, every light year spanning the gulf between galaxies, each one is a gentle testimony to the unhurried nature of the universe. The cosmos is not in a hurry. It unfolds at its own pace, and in learning to think in light years, in learning to accept that meaningful travel across the interstellar distances would consume time we cannot easily fathom, we begin to synchronize ourselves with that cosmic rhythm. We begin to understand that there is no rush, and that perhaps, in the deep silence between stars, there never was one. And yet, the interstellar medium is not truly silent, nor entirely still. There is a gentle rain falling through it, a rain of particles and light that has been traveling for millions of years. These are cosmic rays, high-energy particles born in the violence of distant supernovae, flung outward at nearly the speed of light, drifting through the cold dark on journeys that seem to have no ending. They are, in a way, the universe's slowest whispers, carrying news from the edges of unimaginably distant catastrophes. These cosmic rays are mostly protons, the nuclei of hydrogen atoms, though some are heavier elements, iron and carbon and silicon, all accelerated to almost incomprehensible energies in the furnace of a dying star's final collapse. When a massive star exhausts its fuel and implodes, the rebound is so violent, so monumentally fierce, that it tears through the star's outer layers and hurls them into space. And caught in that shockwave are these particles, accelerated to speeds that would take them across the galaxy, in timescales that dwarf human history. Some travel at more than 99.9% the speed of light. They have been crossing the dark for so long that they might have left their home star long before our Earth even formed. What is remarkable is that these ancient travelers do not simply vanish into the void. They continue on, through the sparse interstellar medium, through systems and clouds and nebulae, drifting as solitary messengers. Some take millions of years to cross the distance between stars, yet their journey is patient, unhurried, almost meditative. They pass through the thin veils of hydrogen and dust without resistance. There is nothing to stop them, nothing to slow them down. The emptiness itself becomes a highway, a vast transparent corridor where these particles can wander indefinitely. And here is where the story becomes even more calming to contemplate. These cosmic rays, these ancient visitors from dead stars, eventually find their way to Earth. Some of them, a constant gentle rain, penetrate our atmosphere every single day. When a cosmic ray strikes an air molecule high in our sky, it creates a cascade of secondary particles that drift downward like snowfall, eventually reaching the ground, becoming part of the air we breathe, the atoms in our bodies. We are, quite literally, being touched by the dust and light of distant supernovae that exploded long before our sun was born. This is not a frightening thing, though radiation carries that word with it, heavy with warning. Rather, it is a profound connection. The cosmic rays that reach us have journeyed so far, survived so much, drifted through such immensity, that by the time they arrive at Earth, they have become almost gentle. They add a faint background hum of radiation to our world, nothing harmful, nothing overwhelming, just a distant reminder that we are never truly isolated, never truly alone. The universe is always reaching toward us, in the gentlest possible way. The journey these particles take is almost incomprehensibly slow when measured against human time, yet incomprehensibly fast when measured against the age of the cosmos. A cosmic ray that left a supernova in what we now call the Crab Nebula. That explosion, witnessed and recorded by Chinese astronomers in the year 1054, might still be traveling through interstellar space today, 970 years later, having crossed a distance of hundreds of light years, moving at relativistic speeds, yet still not having reached its destination. Some cosmic rays have been traveling for eons beyond measure, drifting through the galaxy, passing through countless star systems, and we encounter them as if they were always meant to arrive here, on this quiet world, in this moment. And the radiation they bring is not uniform. The interstellar medium is crisscrossed with patterns of magnetic fields, invisible threads of force that weave through the void, deflecting these cosmic rays slightly, bending their paths, though never stopping them entirely. These magnetic fields trace the structure of the galaxy itself. They guide the cosmic rays along winding roads through space, creating zones of higher and lower radiation density. In some regions of interstellar space, the shower of cosmic rays is heavier, in others, lighter. This is all happening silently, invisibly, a dance of particles and fields occurring on scales so vast that a human mind can barely hold the concept. What makes this restful to consider is the constancy of it. Cosmic rays have been falling through the universe for billions of years. Before there were planets, before there was life, before there were eyes to see the stars, these particles were already journeying through the dark, already creating their cascades when they encountered the rare atom or molecule. They will continue long after Earth is gone, long after our sun has expanded and cooled, long after every trace of human thought has dissolved back into the cosmic dust from which it came. They are patient. They ask nothing. They simply move through the emptiness on paths laid down by forces so ancient and so vast that we can barely comprehend them. The radiation environment of interstellar space, then, is one of these great paradoxes that settles the mind rather than troubles it. It sounds dangerous. Radiation, cosmic rays, high-energy particles. Yet it is really just the gentle, patient flow of matter and energy from the oldest, most distant corners of the universe, reaching toward us, becoming part of us, reminding us that nothing is ever truly isolated. The boundaries between stars are not walls but passages. The silence of space is not empty but full of this quiet, endless drift. And in knowing this, in truly letting the image rest in your mind, cosmic rays from supernovae, falling through the dark for millions of years, eventually touching Earth's atmosphere, becoming part of the air and water and soil around us, there is a strange, deep comfort. We are connected to those distant explosions. We are made, in some small way, from the remnants of their violence, transformed by time and distance into something gentle, something that nourishes rather than harms. The universe is vast and cold, and almost incomprehensibly empty, and yet it reaches toward us always, slowly, patiently, as if we were always worth the waiting. Within all of this vast emptiness, drifting through the darkness between stars, exists something deeply humbling, a substance so fine, so ancient, that to hold it would mean holding the memories of dead worlds, the dust of interstellar space. Not the dust you might brush from a forgotten shelf, but particles so small they measure in fractions of a micron, grains born in the furnaces of stars that died long before our sun was born. Consider for a moment what becomes of a star when it reaches the end of its life. A massive star, having burned through its hydrogen, begins to collapse inward under the weight of its own gravity. The pressure and heat at its core becomes so intense that the star begins to forge heavier elements: carbon, oxygen, silicon, iron. And then, in its final moments, something extraordinary happens. The star explodes. A supernova releases that material, all those newly forged elements, all that stellar ash, outward into the interstellar medium at speeds that would seem impossibly violent, yet in the scale of cosmic time it is almost gentle, like an ancient being slowly releasing what it has carried. This is how interstellar dust begins. Each grain carries within it the atomic signature of the star that created it. If you could examine a single speck of dust floating in the dark between Proxima Centauri and the nearest neighboring star, you would be looking at matter that has journeyed through space for perhaps 4 billion years or more. You would be holding, in essence, a fragment of a stellar corpse. And yet there is no sadness in this fact. There is only transformation. The dust clouds that hang in the interstellar medium, those dark nebulae that block the light of distant stars, are not merely graveyards of dead suns. They are maternity wards. Within these vast, cold regions where gravity works with infinite patience, these recycled particles slowly accumulate. They gather together, grain by grain, particle by particle, over millions of years. The magnetic fields that thread through the interstellar medium guide this slow dance. The gravitational pull that seemed so gentle in one location becomes stronger when billions upon billions of grains concentrate together in a cloud, and gradually, slowly, inevitably, a new star begins to form. Think of what this means. The iron in the iron oxide grains drifting through one particular nebula may one day form the core of a planet. The carbon in those dust specks may one day become part of a new sun, burning for 10 billion years. The very atoms that once composed a star that died before humanity's species even existed are destined to become part of new stars, new planets, perhaps even new worlds, where chemistry becomes complex enough to support life. Dust remembers, not in any conscious way, but chemically, physically. The universe carries forward what has been and transforms it into what will be. Every dust particle in interstellar space carries this connection backward and forward through time simultaneously. When you breathe air on Earth, some of the oxygen molecules in your lungs were once forged in stellar furnaces. Some of the carbon in your cells came from a supernova explosion. You are not separate from this cycle of stellar death and rebirth. You are woven into it. The dust between the stars is not lifeless matter. It is the library of creation, holding the information of what was, waiting patiently to become what is next. The size of a typical interstellar dust grain, if you could somehow perceive it, would be somewhere between 1/10,000th and 1/1,000,000th of a meter, smaller than most bacteria, and yet these infinitesimal fragments are the scaffolding upon which all future cosmic construction depends. Without them, there would be no planets. Without them, there would be no possibility of the chemistry that leads to life. A single particle so small as to be invisible contains the inheritance of distant suns. The color of interstellar dust clouds tells another story. Some appear reddish, some blue, some so dark that they block all visible light. The reddish clouds often contain iron oxides and other compounds born in supernovae. The bluish reflection nebulae occur where starlight scatters off the dust, revealing its presence. And the black clouds, the darkest regions, are the nurseries where the dust has grown so thick, so concentrated, that light cannot pass through. This is where stars are born, where atoms that once were part of a dead sun begin the slow, patient assembly into something new. In the darkness, in the nearly perfect silence of interstellar space, this transformation occurs. No one is there to witness it. No sound accompanies the process. The rebirth of recycled stellar matter happens in complete stillness, over timescales that dwarf human comprehension. 1,000,000 years is merely a breath in this process. Gravity does not rush. The dust does not hurry. There is a profound peace in this knowledge. The universe knows that there is time, always time. The dust will wait. The dust will gather. The dust will become. And perhaps this is one of the most comforting facts about interstellar space, that nothing is ever truly lost within it. Every atom that has ever existed continues to exist. Every star that has ever died contributes to the birth of future stars. The dust between the stars is not an ending. It is a pause, a moment of waiting between chapters, a resting place where the matter of the cosmos is gently preparing for its next transformation, for its next role in the endless cycle of stellar creation and renewal. There exists between the stars a loneliness so profound that it seems almost to have weight, a darkness so vast that the human mind, when truly contemplating it, finds itself moving slower, as though pressed gently downward by the sheer emptiness itself. The nearest star to our Sun, Proxima Centauri, lies 4.24 light-years away. 4 light-years. That distance is so immense that if you were to travel at the speed our fastest spacecraft can achieve, you would not arrive for more than 80,000 years. 80,000 years. In that span of time, civilizations would rise and crumble to dust. Languages would be forgotten. Mountains would wear down to plains. And yet from where you rest now, that nearest star is your Sun's closest neighbor. Beyond Proxima, the gaps grow wider still. Sirius, brilliant in Earth's winter sky, burns 8 light-years distant. Betelgeuse, a giant so massive that if it replaced our Sun the planets would all drift within its outer atmosphere, lies 600 light-years away. 600 years of light, traveling at 300,000 kilometers every single second, and it still has not arrived. In the spaces between these distant suns, there dwells a vastness that can feel, when contemplated in the stillness of late night, almost like abandonment. Star systems float as islands in an abyss, separated by distances that render them utterly unreachable by any human timescale we might imagine. A spacecraft launched today towards Sirius, traveling at its maximum velocity, would not arrive for 2.5 million years. The Earth would have evolved entirely different species by then. The continents would have shifted beneath new oceans. And yet, and here is where the loneliness transforms into something gentler, something almost beautiful. Every atom in that distant space, every particle of hydrogen, every grain of dust drifting in the cosmic dark, shares with you and me a common ancestry. Consider this: the oxygen in your lungs, the carbon in your heart, the iron in your blood, they were all forged in the cores of dying stars. Billions of years ago, when the universe was younger and its stars burned shorter and brighter, those stellar furnaces created these elements. When those stars exploded as supernovae, the shockwaves scattered these newly formed atoms across the interstellar void. Those atoms drifted in the darkness for millions of years. They gathered into clouds. Those clouds collapsed. New stars ignited. Around those stars, planets coalesced. One of those planets was Earth. The atoms were incorporated into the first organisms. They have been cycling through life ever since, passing from one creature to another, continuously recycled, never destroyed, only transformed. You are, quite literally, made of stardust, and so is every being and every stone and every grain of sand on every planet, in every star system in this galaxy. This means that the vastness between the stars is not truly separating strangers. It is the space between different moments in the life of the same family of matter. When you consider the hydrogen clouds drifting in the space between Proxima Centauri and our Sun, you might ask, are those atoms not also part of the same story? Did some of them not once orbit in the atmosphere of some ancient world? Might some of them not, in a future epoch stretching into unimaginable time, become part of a creature looking up at a different sky, wondering about the distances between its home and other worlds? The loneliness of interstellar space, when viewed this way, becomes something else entirely. It becomes less a separation and more a space of patience. The atoms are waiting. They are drifting slowly through the dark, pulled gently by gravity, guided by magnetic fields, moving at velocities measured in kilometers per second, yet covering distances so enormous that even at those speeds they require millennia to traverse from one neighborhood of stars to another. But they are moving, they are connected. The universe, in all its vastness, is fundamentally not isolated. It is a single, slow conversation between light years, a continuous recycling of the same precious materials across epochs that dwarf human history into something barely measurable. And perhaps this is what makes the vast emptiness between the stars not tragic but restful. You are not alone in the universe because the universe is not made of separate things. It is made of connections stretched across impossible distances, yes, but connections nonetheless. The same atoms that once formed the core of a star now form you. The hydrogen clouds that drift in the darkness between distant suns contain particles that were once part of you and will be part of you again in ways we cannot predict. In this sense, the distance between star systems is also, paradoxically, an intimacy. It is the intimacy of belonging to something so vast, so ancient, and so completely interconnected that no individual piece, no atom, no person, no world can ever truly be separated from any other. So the loneliness transforms into communion. The vastness becomes, in a quiet way, a comfort. You are home in this darkness because the darkness, like everything else, is you. Yet somewhere in this vast and patient darkness, travelers arrive. Objects born in the orbital chaos of distant star systems, cast loose by the gravity of young planets, drift across the interstellar ocean with no destination, no purpose save motion itself. And on rare, almost precious occasions, one of these wanderers passes through the reach of our own sun, arriving as a visitor from shores we will never see. The most famous of these arrivals came in the autumn of 2017, when astronomers detected something moving through the solar system in a way that immediately seemed wrong. They called it Oumuamua, a Hawaiian word meaning messenger from afar, and what made this messenger so deeply unusual was not its presence, but rather the trajectory it followed. Unlike the comets and asteroids born in our own cosmic neighborhood, Oumuamua was not bound to the sun by gravity's invisible tether. It was simply passing through, a guest whose visit would last only months before it continued outward into the cold and silence, never to return. When you contemplate the odds of such an encounter, the numbers become almost dreamlike in their scale. The space between stars is so profound, the distances so immense, that the probability of any object from another system drifting close enough to be detected should be vanishingly small. Yet the mathematics suggest that many such visitors have likely passed through our solar system unnoticed, traveling through the darkness while Earth's inhabitants slept and worked and lived their brief lives, entirely unaware of the cosmic wanderer overhead. Perhaps dozens have crossed our path in the centuries of human history, visible only to the quiet mathematics of trajectories and orbital mechanics. Oumuamua itself remains shrouded in gentle mystery. The observations suggested it was perhaps 300 meters long, elongated and narrow, tumbling through space in a slow and methodical rotation. Its surface was dark, absorbing almost all the light that reached it, and somewhere in its ancient composition were the secrets of how it had formed, in which stellar nursery its atoms had gathered, which planetary system had ejected it into the void. That information traveled with the object, locked in its form, carried forward as a kind of memory that we could only read in fragments and approximations. What strikes something profound in the human mind is the thought of origin, of journey without destination. This object had crossed countless light years of emptiness, had drifted through molecular clouds and past distant suns that it would never orbit, had survived the radiation and cosmic rays and subtle gravitational tugs of innumerable stars, all to pass by our small world for a few weeks, observed by instruments humans had built, before vanishing again into the deep. In a strange way, it was a reminder of connection, that even in the vastest loneliness, matter from other worlds brushes past our own, that atoms born in unimaginable distances find themselves, however briefly, in the same neighborhood. The detection of Oumuamua changed something in how we think about the space around us. It suggested that the solar system, though it feels like a kind of sanctuary of ordered orbits and stable patterns, was actually more like a harbor open to travelers. Objects from the Andromeda Galaxy, from the Oort clouds of distant systems, from places whose light takes so long to reach us that the photons left on journeys that predated human civilization. These things might be moving among us even now, their presence unknown, their stories written in elements we have never catalogued. There is a quieting thought in this. Each such visitor carries with it the memory of another sun, another system, another story. And in the moment it passes through our solar system, even undetected, it is bound to us by proximity, by the brief sharing of space. The atoms in these visitors are the same elements found in the mountains of Earth, in the water of the oceans, in the bodies of every living thing. A wanderer from an alien system is not truly alien at all, but rather a distant cousin, carrying in its substance the echoes of common births in stellar furnaces, of supernovae that scattered their remnants across different regions of the galaxy. The future may bring more such discoveries. Telescopes are becoming sensitive enough, rapid enough in their surveys, that we may detect more interstellar visitors as they pass through. Each detection will add another page to the slow and gentle catalogue of cosmic wanderers, and with each arrival, we will be reminded of how connected even the distant stars truly are, how matter circulates through the galaxy in ways both random and ultimately coherent, how nothing is ever truly isolated in the dark. And yet, even now, in this moment of quiet knowing, human imagination reaches forward into that vast dark with a patience that is only just beginning to take shape. For centuries, we have dreamed of crossing the stars themselves, not merely sending our instruments ahead into the void, but carrying ourselves, our bodies, our curiosity, our need to witness with our own eyes, across the unimaginable distances that separate one sun from another. These dreams have grown more specific, more tender, more real in their contemplation. Consider the generation ship, that quietest of all human aspirations. It is not a vessel meant to arrive within a single lifetime, but rather a floating world that knows from its launch that centuries will pass before its destination. Imagine a craft designed not for speed, but for endurance and the gentle continuity of life itself. Aboard such a ship, children would be born to parents who never knew Earth, and those children would grow old, watching the same stars wheel slowly overhead through observation ports, knowing that they themselves would not see the arrival, but that their descendants might. There is something profoundly soothing about this vision, the idea that a journey could be so patient, so deeply rooted in trust across generations, that no single human need shoulder the burden of completion alone. The mathematics of such a voyage are almost meditative to consider. A journey to the nearest star beyond our Sun, Proxima Centauri, lies some 4.24 light-years away, a distance so vast that traveling at speeds we might one day achieve, perhaps a tenth of the speed of light, the voyage would still consume more than 4 centuries. 400 years. That is longer than the time separating us now from Shakespeare, from the printing press, from the first telescopes turned toward the night sky. Yet in the minds of those who study such possibilities, this span does not feel impossible. It feels, rather, like a kind of meditation, a very long breath, held across the expanse of human civilization itself. Some dreamers have imagined vessels that might move even more slowly, and thus more peacefully still. Ships powered by light itself, what engineers call solar sails, gossamer sheets of material so thin, so delicate, that they would catch the pressure of photons drifting across the void, and be gently pushed forward, decade after decade, millennium after millennium, gathering speed so slowly that acceleration would be almost imperceptible to those aboard. To travel by the gentlest possible force, moved only by starlight and patience, there is poetry in that, and also a kind of wisdom. No desperate engines roaring, no violent thrust, only the ancient light of distant stars, touching a sail and carrying it forward through the silence. And what of those who travel in such vessels? The thought experiments grow quieter still. Some imagine that crews might enter a kind of hibernation, their bodies slowed almost to stillness, their consciousness dimmed or suspended, dreaming in the cold darkness for centuries at a time. They would wake, perhaps, only briefly, or perhaps not at all, until arrival neared. Others envision societies aboard generation ships that bloom and change across the ages, complete unto themselves, with children born into communities that know nothing of Earth except through stories and archives. Would their lives be lonely? Perhaps. But would they also be profound in a way our accelerated, earthbound existence can scarcely imagine? The question hangs in the dark, like a gentle inquiry that needs no immediate answer. There are other possibilities, still more tentative, still more bound up in speculation, yet worth holding in mind as we drift towards sleep. Some scientists have mused about propulsion systems not yet discovered, ways to bend the fabric of space itself, to create bubbles of warped geometry that might allow faster-than-light travel without violating the laws we know. These remain thought experiments, theoretical gardens where imagination can wander without constraint. Yet even these dreams carry a curious serenity. They are not dreams of conquest or haste, They are dreams of curiosity, sustained across centuries, of humanity willing to invest patience and resources across generations to know what lies beyond the next great distance. And perhaps most peaceful of all is the simple fact that none of this need be rushed. The stars are not going anywhere. Proxima Centauri will continue its slow orbit in the depths of the galaxy, whether we reach it in 4 centuries or 4 millennia. The interstellar medium will continue its patient dance of hydrogen and dust, whether we venture into it tomorrow or 1,000 years from now. There is no timer ticking down, no urgency hidden in the mathematics. There is only the vast, deep quiet of space, and the slow unfolding of what humanity might become if it learned to think not in years or decades, but in the longer rhythms of centuries and the patient hope that connects one generation to the next. The beauty of these distant dreams, of generation ships and solar sails and futures measured in ages rather than moments, is that they soften the boundaries between ourselves and the cosmos. They suggest that we are not separate from the vast dark, struggling against it, but rather participants in a much slower, much vaster story. To imagine sending our descendants into that silence, trusting in their wisdom and their wonder, is to acknowledge that we are merely one verse in a song that will continue long after we have ceased to sing. And in this acknowledgement there is rest. And so we arrive at the true nature of what interstellar space becomes when we stop measuring it, when we release the urgency of distance and speed, and simply allow ourselves to drift within its character. This is where the restlessness of the human mind finds its answer, not in movement, but in the profound permission to be still. The spaces between stars are, in a very real sense, the universe's own resting chambers. Time does not rush there as it does in the crowded hearts of galaxies or near the violent surfaces of burning suns. The light that travels through these voids carries no urgency with it. A photon that left a distant star millennia ago drifts now through the darkness at exactly the same pace it always has, undiminished, unworried, asking nothing of the space it moves through. When we contemplate this journey, this ancient, unhurried passage of light, something in us begins to synchronize with it. We feel the release of speed itself. Consider the atoms suspended in interstellar space, those hydrogen nuclei and scattered dust grains that hang in the emptiness. They move, yes, but with such slowness that the passage seems almost like stillness to our earthbound senses. An atom drifting through the void might travel for thousands of years before encountering another atom to collide with. This is not the frantic collision of particles in the superheated cores of stars. This is meditation, made physical. This is the universe itself settling into a state of deep, patient waiting. The cold you would encounter there, at 2.7 degrees Kelvin, is not the sharp, stinging cold of winter on Earth. It is an ancient cold, a calm cold, the baseline temperature of the universe itself, inherited from the cooling that followed the Big Bang. It is, perhaps, what silence would feel like if silence had temperature. It is the very essence of absence given form, yet it is not hostile. It simply is. It surrounds everything with a gentle, impartial embrace. In interstellar space, there is no weather. There are no storms except those that occurred billions of years ago and have now frozen into the slow motion of cosmic structure. There is no rush of wind, no sudden change, no day turning to night. There is only the steady continuation of what has always been. The darkness does not become darker or lighter. The cold does not fluctuate with the seasons. Everything is held in an equilibrium so profound that the very concept of change seems almost foreign. Time itself moves differently in our perception when we contemplate these voids. What would it mean to travel through such a space? Not in the frenetic way we imagine space travel, with our rockets and urgency, but in the way a cloud of dust drifts through the ages, barely aware of the centuries passing. You would age, yes. Time would still move forward for you as it moves forward for all things. But the space around you would offer no resistance, no urgency, no reminder. You could float for 1,000 years and arrive at almost the same place you began, and no one would rush you. No one would ask why you were so slow. The magnetic fields that thread through interstellar space, those invisible architectures that guide the dance of particles and cosmic rays, work with the same patience. They do not push or fight. They gently shape and guide, like an old hand steering a river that has flowed in the same direction since time began. These fields form structures so vast that human brains struggle to contain their scale, yet they move and settle with the slowness of geological time, or slower still. Perhaps this is why interstellar space holds such quieting power over the human imagination. We live in a world of constant stimulation, of demands and deadlines and the urgency of the present moment. We are bombarded by information, by choices, by the need to respond quickly and adapt faster. But interstellar space offers the opposite. It offers a realm where none of that matters, where patience is not a virtue but a simple fact of existence, where you could rest for eons and the universe would not notice, would not judge, would simply continue its ancient, unhurried cycling. The vast stretches between stars are, in this way, a kind of cosmic sanctuary, a place where the fastest thing present, light itself, still takes years to cross from one sun to another, where the most energetic events, supernovae and neutron star collisions, are so distant that their light arrives as a gentle whisper after its long journey through the dark, where the loudest events in the universe arrive in absolute silence. And in that silence, there is a kind of deep permission to stop striving, permission to let thought settle like dust in a still room, permission to exist without purpose or urgency, simply as part of the vast, patient fabric of creation. This is what the interstellar medium offers to the contemplative mind. The assurance that vastness and emptiness and quietude are not empty of meaning. They are full of a different kind of meaning, a meaning that requires no words, no motion, no proof. The loneliness one might expect to feel in such expanses often transforms, when truly considered, into something else entirely. Not loneliness but solitude, not abandonment but autonomy. In the spaces between stars, you would be held by the same physical laws that hold the entire cosmos in its gentle, unbroken dance. You would be connected by the same atoms, the same forces, the same fundamental particles that make up everything, from the stones beneath your feet to the breath in your lungs. Distance, in this sense, becomes not a separation but a kind of closeness, a shared membership in the quiet unfolding of all that is. And here, at last, in this image of interstellar space as the universe's own resting place, we find ourselves approaching the deepest relaxation, not the relaxation that comes from escape, but the relaxation that comes from finally understanding that there is nowhere else you need to be. The cosmos has been resting here, in this vast quiet dark, for billions of years, and now, in your imagination, you rest here too. And so, as we drift back from the edges of that immense silence, it becomes clear that we ourselves are not separate from it at all. We live, all of us, on a small world wrapped in warmth and light and air, a place so vivid, so crowded with sound and motion and meaning, that it seems almost impossible to believe the void surrounds us. Yet it does, and perhaps that is not something to fear, but something to rest in. The Earth, seen from the perspective of interstellar space, is a pale blue sphere suspended in infinite dark. It circles a middle-aged star that has been burning for 4.5 billion years and will continue burning for billions more. That star, in turn, is one of roughly 200 billion others in our galaxy alone. and our galaxy is one of 2 trillion in the observable universe. The numbers have a way of dissolving into abstraction when we contemplate them, but they also have a way of becoming strangely peaceful. We are so small, our worries, our rushing, our hurried lives, they exist in this tiny pocket of warmth and order, held aloft by the steady fusion of hydrogen in a stellar core. There is something profoundly comforting in that smallness. Think of it this way: the vast emptiness we have been contemplating throughout this journey, that near-perfect vacuum, that ocean of near-nothing between the stars, it is not hostile. It is indifferent, yes. It contains no will to harm us. It is simply there, patient, ancient, waiting. And our world, our small, warm world, has carved out a space within it. We have not conquered that space. We have not bent it to our will. We have simply found a way to exist within it, to flourish within it, beneath the shield of our atmosphere and the warmth of our sun. The sunlight that falls on your skin right now, if you could see it from the vantage point of interstellar space, you would understand that it is a luxury beyond measure. That light has traveled 8 light minutes through the void to reach you. Every photon is a messenger from a star, a carrier of energy that began as a nuclear reaction in the sun's core. And between that star and your body lies the vacuum, the emptiness, the hydrogen clouds, the dust grains, the cosmic silence. And yet that light makes the journey. It reaches you, it warms you. It gives life to the green things that grow, to the creatures that move, to the civilizations that build and dream and wonder. When you close your eyes tonight, know that you are resting in a pocket of exceptional fortune. You are surrounded by darkness. Yes, the same darkness that fills the vast distances between the stars. But you are also surrounded by warmth, by air that carries oxygen, by the presence of other beings who share this small, bright world with you. The stars above, the ones you might see if you venture outside on a clear night, they are not truly distant in the way that matters. They are distant in space, yes, millions or billions of miles away, but they are connected to you. The iron in your blood comes from stars that exploded before the sun was born. The carbon in your bones was forged in stellar furnaces. The oxygen you breathe was created in the heart of massive stars that have long since ended their lives. You are made of stardust, truly, literally, and that same stardust is drifting, even now, through the interstellar medium, slowly, infinitely slowly, gathering itself into the seeds of future worlds. In the darkness between the stars, time moves differently than it does here. The light from a distant star takes years, or centuries, or millennia to reach us, and by the time it arrives, that star may have changed, or died, or moved to a new place in its orbit. We see the universe not as it is, but as it was. We are looking backward, always, into the past. There is something restful in that thought. The universe we observe is peaceful, in part, because it is ancient history. The violent supernovae we study happened so long ago that they are now only gentle light, arriving softly at our eyes. And what of the future? What lies ahead in the great dark? We do not know. Our telescopes can see only so far. Our instruments can measure only so much. The universe beyond the horizon of what we can observe, it remains, in a deep sense, mysterious. Perhaps there is comfort in that mystery too. Perhaps it is right that we should never fully understand everything. There should always be more darkness to drift into, always more silence to listen to, always more vastness beyond the reach of our understanding. The generation ships that humans may one day build, those slow caravans that might carry our descendants across the interstellar gulfs, they will carry stories and music and memories of Earth. They will carry the memory of what it felt like to be born on a warm world beneath a yellow star. They will carry the knowledge that we once stood in a garden, under an open sky, and wondered at the lights above. And perhaps that is the greatest gift we can give to the future, not the conquest of space, but the memory of home, the warm knowledge that here, in this small pocket of order, we existed, we lived, we loved, we looked up. For now, though, there is rest. There is the darkness outside your window, which is the same darkness that fills the spaces between the stars, but made gentle and near by the walls of your room, by the familiar shapes of your surroundings, by the steady rhythm of your breath, and the slow settling of your thoughts. The universe continues its vast, unhurried work all around you. Hydrogen gathers into clouds, dust grains spiral slowly toward each other, light travels across unimaginable distances. Somewhere in the deep dark, new stars are being born, and here, in your small warm place, in this pocket of comfort and stillness, you are safe, you are held. You are home, the cosmic microwave background radiation that bathes us all, that ancient echo of the universe's earliest moments. It surrounds you even now. It is 1 degree above absolute zero. It is the warmth of creation itself. It is the universe's way of reminding us that we are not separate from it. We are part of it. We are the universe, become conscious of itself, resting in the dark, wondering at the stars. Let that thought settle as your eyes grow heavy. You are dust and starlight and water and time. You are a temporary arrangement of atoms that once belonged to distant suns, and you are resting now, safely, in the gentle, eternal dark.